Our project was sponsored by EPRI. EPRI created an eddy current array sensor to detect cracks in a nuclear spent fuel pool lining. Our team designed a tool to transport the sensor.
This part of the design focuses on providing structural stability for the lower portion of the device, while being capable of providing accurate positional control of the assembly along the safety rails. Key safety features are located below the rolling axis, with two spring-loaded levers that act to encapsulate the rail and catch the device should the rollers ever slip off the rails. Finally, the system utilizes 4 quick-release clamps that allow the lower part of the device to be positioned to fit the pool configuration.
This is the carriage as seen from the inside of the pool. Shown is the clamp knob, which is loosened to adjust the probe angle. Not shown is the drive belt, which attaches to the carriage mount. This is the operator view of the carriage. Clearly shown are the linear slide bearings on the carriage, the angle indicator inscribed on the carriage mount, and the ECA probe mounted inside of its case. This is the configuration of the rails for storage. Once unfolded, the hinges lock into place, keeping the rails rigid during operation.
Moving down to the bottom mount, which will support the constant contact with the wall, it will be connected to the rails using 4 screws. Permanently lubricated and sealed rollers and bearings were used. The rollers will be press-fitted onto 2 shoulder screws as seen, while the bearing will be press-fitted onto the mount and subsequently the pulley shaft. The pulley shaft is then connected to the pulley that will support the belt and carriage movements. Moving up to the moment arm, a cast iron moment arm is utilized at the top steel rails to make sure enough moment is induced in the system to keep the bottom mount flush with the wall.
The motor system is comprised of 2 software-controlled servo motors that will control the X and Y axis movement. Both are enhanced with anti-resonance and vibration suppression technology that will reduce feedback to the ECA sensor. The motors are powered by a 4-axis power hub that's powered by a hybrid power supply that takes in 120 volts AC and converts to 24 to 90 volts DC. The motors are controlled by the ClearView software included or by any Arduino IDE.
FME is a process used to make sure any foreign material stays out of the tool, and to avoid any foreign material contaminate the delivery tool, which can cause corrosion over time. To secure the fasteners in the tool, there are some type of locking mechanisms that will going to be used, such as nylon locks, thread lockers, and spring washers.
In conclusion, our design was successful. Next steps would be to construct the tool for further testing.